right. Am I live? That's a good question. Let's go here and test. Update. Let's do a test. Okay, let's go here. Okay, I'm live. Good. Right. Okay. So I'm just doing a real test here. I'm just testing the system basically to see if it's working. Something I want to mention, this is something, it's more of a public service announcement as it relates to us who do blue sky science versus people that actually work for a living. And when I say that, I'm not trying to offend any of us who do research, because I'm one of them too. But I grew up in a construction family. I grew up in construction. I still do construction to this day. If I go home, I work with my brothers. I'm always their laborer. I'm basically useless with my hands, but I'm flies everywhere. I'm literally living in a construction site as we speak. My brother has bought a piece of property with an old house on it and a separate garage, and now we're renovating. So we're building him a huge shop so we can store his RV and cars, etc., and also put in a cement driveway, etc., which you can see here on the result. So let me just play this.
Starting to pour.
Here's guys that work for a living. Like, I mean, this is hard work, okay? Chris is the foreman here. He's going to be operating the leveler, which is this machine here.
Moving it backwards.
And as they're pulling the cement backwards, he'll start operating this to smooth it over. Okay? And it's a real team effort.
From a distance, it looks good.
So here you are. You can see Chris at the helm doing his work.
Cleaning it up.
This character is tooling the sides to give it a nicer look. But there's a real effort, 4 or 5 guys, and this driveway is 800 feet long. So they're going to do it in 2 pours. This is the start of the first pour. They've already poured all of this concrete a week before. So it's already firm enough to walk on. Okay? So I'm going to go to the third and final clip I want to show you.
This is truck number 3.
And here we are here.
Poured, so you can see how far 2 have got them. 20 feet each, so it's going to be a number of trips. I think there's 3 trucks. They're just rotating in and out. So they'll make a number of trips each from their factory, which is nearby here.
Okay, so in effect, you can see what they're doing here. Now they have a tool which they use to sweep across here to give it a swept-looking effect, so it gives it sort of enough roughness that you get tire traction. The key is if you make it too smooth, of course, if there's water or ice, big problem, especially in Canada. They'll do tooling around the edges, and then they've done tooling here, every certain so far out. But the most important point I want to show here is that this is freaking hard work. Because if it rains, this is a problem, okay? So it's weather dependent. If it's cold, they have to add special materials into it, like a lithium form of antifreeze. So it's hard work, but it's also a form of science because, you know, just doing the leveling, they were using laser levels here to make sure the boards are the right height. They poured the right amount of thickness. They put down the rebar, etc. And these people seriously work for a living. Okay? Those of us who are astronomers, of course, we spend our life producing things like this. So this is a data set that I've created, and it's been taken from Dave MJD 5500 all the way up to 10,600 or to date, okay, to date. And this is, you can see here it's velocity on the y-axis, time on the x-axis, and we're seeing a form of velocity drift that is nonlinear. And more importantly, the blue and the red are not the same. So the blue is left circular polarization, the red is right circular. And we would have thought that these 2 sources, or these 2 masers, are in fact a Zeeman pair. Okay? Now, there's a couple hundred observations here taken, and it took me an hour to process each one of them. So it's a couple hundred hours just to process the data, and then I'll spend time feffing with software, whatever, to create this actual image here, and I'll spend time staring at this. But as I said to you, if you're staring at data and you're working on a computer, do you really think you're working as hard as the guy who's pouring concrete? And the answer, of course, is no. We will all agree that those people who work outside in the heat, the mud, the wet, the snow, the wind, all the weather, they're going to work a lot harder than we have. And so what is it that we give them? What do we give back? Because remember, that guy working hard or that woman working hard is producing something that pays taxes. The customer will pay taxes on that work or will make money, pay taxes. Some of their money they'll spend to these workers. They will in turn get an income, pay taxes. And that money gets paid for people like us researchers to make a graph like this. So when I listen to people telling me how difficult life is and they're moaning and complaining because they didn't get observing or whatever the travails they've had for that particular or perceived grievance that they have. And believe me, there is many. There's always, doesn't matter where we are, you're always going to get people that bitch and gripe. Other people are very grateful. But I can assure you, when I went from working construction to pay my way through school and being one of those guys laboring at that concrete or carrying heavy rocks or working up on high scaffold or whatever, or mixing cement in cold weather, I mean, I got to tell you, when I got a job in astronomy, it was like heaven. Someone paid me to have fun, right? So I just want to sort of, this is sort of like a gentle reminder to all of our researcher friends, astronomers, biologists, whatever. Any of us that do work in blue sky science, please remember that you are doing this, you're able to do this because somebody is willing to go outside and work their ass off to build a house and in turn pay taxes that pays you. And it's true for the farmers at work, the truck drivers, the restaurateurs, the waiters, waitresses. I don't care what the politically correct term is. The simple answer is these people really work for a living. Okay? Sitting at our desk swilling coffee. And again, I'm not trying to be insulting. Please understand, I am not trying to insult or offend any of us, including myself. You know, I like to think of myself as a working class astronomer. What I mean by that is I toil away for long hours, you know, basically processing and then staring data like this. But the worst I get is sore fingers or sore eyes. Okay? And I can assure you, when they're pouring the concrete, I'm not doing it this time because we've contracted it out to somebody else, but I'm the person, you know, maintaining the property and stuff like this, literally living on a job site. So, you know, I'm quite happy to accept that sort of rough living because the benefit it gives to my brother, and more importantly, he allows me to do this. So I'm very appreciative, you know, and you know, it's my way of paying for my hobby effectively. I would love to get a permanent job. I've never had one. I've always worked contract. So for us students, for those students that are graduating, and this is especially true, you get into the postdoc cycle and you'll start working postdocs. Be very grateful, firstly, that you're getting that opportunity. Be very grateful. You know, please do try to look at the very positive side of this, because otherwise you could find yourself out somewhere trying to do another job like sales or what have you, or other jobs where it's much more physically demanding, where you're going to have to work your backside off to provide for you and your families. Okay? You know? Now, like I've always believed, construction work is good, honest work. And I don't mean that, like I said, I mean it in a positive sense. I find that when I do construction with my brothers, first off, I get to work with my brothers. And more importantly, it reminds me of working with my dad. And effectively, I feel like I'm doing something. So at the end of the day, I'm cold, wet, tired, sore, but I can see what we've done when I walk away. and I can go to bed tired, sore, whatever, and I wake up the next day and I get to go back to work and talk to my brothers. Okay? So for me, there's no negative to this. And there's certainly no negative to doing astronomy. When I go to the office and I process data and I look at images like this, it's taken me a long time to produce this. Okay, just writing the software to make the graph, I have to and fiddle all these things to get everything nice, whatever. And this is true for everybody that does this. Okay? But in the end, just remind yourself, out there in the world, there are people doing hard work. There are people paying taxes that in turn pays for you to get the joy to do this. You're given the privilege to do this, because I don't know of too many astronomers that get paid from construction jobs or what have you to actually do astronomy. The majority of us get employed by institutions like universities, observatories, and places like that in order to do astronomy. So we have to start thinking of what we could give back to the taxpayer, right? And the real answer is, I think all of us know this, in fact, it's outreach. So that could come in the form of doing a publication like this and providing it to the media so they can present an interesting story to their readers. And those readers are the taxpayers paying for our jobs. Okay? The other way we do it is we do outreach, which is the key. So we will go out and give presentations to the public and that. And I got to tell you, what I found, the vast majority of astronomers in particular, but all scientists, really enjoy doing that because they like what they do. And that's the key to life. Be passionate about what you do, enjoy what you do, and impart that enjoyment to all the others who are paying the bills so that you can do this observing. Okay? So I think we have to always, be cognizant of who's paying our salaries. Yeah, we spent 10 years in university getting these degrees. Yeah, we worked our backsides off working, 12, 15, 18, 20-hour days in order to get those degrees, and then sometimes to do research in general. Or we have to go to very odd places to do this research sometimes. Well, today less so, but still. But the bottom line is, none of it is as difficult as what these people are going through. Okay, if you're an observer at the South Pole for a year and you're wintering over and you're away from family and friends and you're isolated in a place with no sunlight for 3 months, okay, I will accept that's a difficult job, okay? And you're working in incredibly difficult conditions at the South Pole. I would love to do it. I would honestly love to do it, but I will never get that chance, I don't think, at least at my age. But outside of something like that, you've got to see yourself as a, I'm going to turn off something that's driving me nuts. Where is this thing? That's good. So as long as I know that the thing's working, I'm watching on one computer while I'm broadcasting. So you would honestly have to look out at the world and everybody around you and then realize that, hey, give something back to them, even if it's just your passion in what you do. Like if you're a botanist or a biologist or an ichthyologist, I don't care what it is. Give back to the public. When somebody asks you a question, answer them, right? Because it isn't knowledge until we impart it to someone else. Until somebody else understands what we're doing, it's not knowledge. It may be an idea that you have in your head, but if you can't explain it to anybody else, it's not knowledge that humanity can what's the word I'm looking for here? Consume. Okay? So what we do is we feed the minds of the masses, effectively. We become the teachers of their children. We give them excitement. Perhaps, maybe we enthuse one of them to become a scientist like ourselves, but we have to give back to that. And I think that's really important. And something I got to tell you, and to be honest, let everybody be clear here. And remember, I'm probably talking to myself right now. That's okay, because I'm gonna record this. I'm gonna leave it out there for posterity on the internet. But for other people to maybe watch tomorrow or whatever, or never watch it at all, it's not important. It's basically a record that I'm saying to myself. It's reminding me what I must do. So I tend not to be around most people. I tend to be by myself. I tend to be in places where it's very isolated, whether it's where I work or where I live. And as a result of that, I don't get the opportunities that some of you might have to give back, to directly give back. Okay? Now, when I can give back, I'm certainly going to try to do my best to do that. All right? So, but sometimes I too fail. Now, I want to look at this graph for a second again. I want to talk about the science of this graph just for a second. So if I'm going to talk about what I think is interesting, then I should at least tell you something about this graph. And as I pointed out earlier, the red is one polarization, the blue is another polarization. And Hartrell, when it observes, you get two spectra, RCP and LCP. So R for red, so RCP is red, LCP is blue. So you get two polarizations, two circular polarizations. That's all Hart gets. We don't get full Stokes. And we get two independent polarizations, so we have to calibrate them independently. And then when we try to find out if there's circular polarization, we have to recognize that there could be errors. So you can see these two graphs here. I assume that they're a Zeeman pair. In other words, they're exactly the same magnetic field. They're the exact same maser, except when you apply a magnetic field, it splits it into the right and left circular polarization. And there's a gap of a certain number of meters per second or kilometers per second, whatever you have, okay? So in this graph, you can see that there are differences between the red and the blue, the RCP and the LCP. Now, if these were true Zeeman pairs, that tells us that the magnetic field is different. Okay, that's what it tells us. Okay, and this is long-term monitoring. So I haven't given you years here, but basically this is 2024, and we've gone back 5,000 days. So it gives you an idea. That's over 10 years ago, right? So that's basically almost 15 years before. So this is 2010 or something like that. Whatever. I can't remember. I'm getting lazy. I'm tired. But anyways, so this is long-term monitoring. I do lots of observations, and you can see other stuff in here too. So if we look at the blue for a second, and it seems to have a much closer, has a much smaller deviation in terms of the spread of the data. And you can see this sort of undulation occurring in here. All right? That undulation is actually the Earth orbit not being circular as it goes around the sun. Okay, so that's the result of eccentricity of the Earth orbit, right? So that just injects something in here. And of course, the person who wrote the VLSR software, the software that converts the frequency of the line center of this molecule, which is hydroxyl, and then has to shift it, Doppler shift it, to account for the motion of the Earth around the sun, and then all sorts of other things like the planets, Earth's eccentricity. Well, some of the things they never corrected for. And so, unfortunately, they did not correct for Jupiter and Saturn, the planets. So that's causing this undulation. And the 1 year annual undulation is, of course, eccentricity of the Earth going around the sun in a non-circular orbit. Okay, but irrespective, if I have this data, because the correction is exactly the same for both, down to millimeters per second, effectively. If that was the case, if I know I've got LNR, and I've got pure LNR, which I may not know, I can subtract the two velocities, and from that I can determine if the magnetic field is actually drifting. And that will be quite reasonable. That'll be quite accurate, simply because, well, it's going to inject a lot of errors, but it'll be believable because no matter what the VLSR correction is, I have to apply it to both the L and the R equally, okay? Because it's unrelated to the L and the R. That's the first thing. Now, something else I have to say to you that would make me wonder if in fact this is a magnetic field variation is that if the flux of the source, if the intensity of the maser is varying, and I'm looking at heavily line-blended features, which these may be because this is a single-dish telescope, it's entirely possible that one feature is, I'm giving you the figure, I won't do that. It's entirely possible that one maser in the line-blended feature is turned off, and that causes the velocity to shift slightly. So it could be that this maser is actually constant, and I'm seeing the Zeeman pair, but there's a second feature or a third feature that has varied in the data that I'm seeing that causes that shift. Okay, so it's entirely possible I'm seeing nothing of magnetic field variation. Something else that gives me a hint that that might be the case is the fact that this feature or these features have been detected for almost since the 1960s, since they first discovered masers. Okay, and since they first discovered hydroxyl masers in the 1960s, 66, this source was monitored in 1966 after the original detection of masers. And it had a velocity feature at around these velocities. Okay, I'd have to correct for the errors they might have had, but the answer is it'll be a flat line over time. So if I then decide to look at a longer time series, which I actually have if I look at the methanol, now I don't think I can see it here. I'll try. I'll see if I've got something that shows what I'm talking about. And if I don't, well, you're out of luck. You'll have to see it on another video. So let's get away. Flies are annoying here this time of year. No, that's not it. Let's go to sources. Let me see if I can find something that's gonna... I'm just trying to find an image. I don't think I'm gonna find it here. Or am I? Let's see what this does. No, it's not doing it. It's on my other computer, so I can't show it to you right now, whatever. But, which is unfortunate. I'm just trying to see if I could see something. Anyways, I can't show it to you. But the point I'm trying to get at is simple. Is that as we're doing this kind of stuff, let's go to there for a second. I know we can do. We can look at other transitions and we can see if the same trend is occurring. And the answer is yes, it is in multiple transitions. And I see it in other sources. So it's pretty apparent to me that the guy who wrote the software at Heart Rail never bothered correcting for the planetary motion and its impact on the wobble of the Earth. So we have to correct for that. So we haven't corrected. So that would have to be subtracted out of this data. And so long story is very short, it was a lot of hard work for me to get to this. But it sure as hell isn't as hard work as the guys that poured 366 feet of concrete in 9 hours. And the reason it took 9 hours is because they had to wait for trucks, because there's other work going on so around the city. So they waited so there was gaps so they could rest, but then they're standing there doing nothing for, whatever. So they'd rather just work constantly. And then they poured the remaining 300 plus feet. They poured that in a matter of 6 hours, to give you some idea of how long it took to do this. So it was about a 15-hour job just to pour concrete on that way. Now that's a hell of a lot harder than me talking about this graph. I just want to give you that comparison. And I can assure you something, I'm very appreciative of the work they did. They did excellent work, really. The finished job is amazing. Let's see if I can give you a picture of that. Let's try our luck. I'll try to give you an image of what the finished driveway looks like. Is this it? That's not it. That's just me sorking around. Let's see. No, that's going inside. That doesn't count. There's all sorts of stuff going on here. But let me see if I can show you. That's a picture of it there, and you can kind of get an idea. And then I'll finish with this once I get this. Where the heck is it? I drove actually along it. That was the part I want to show you. No. No, that's junk. Yeah, this will give you some idea of, this is just a picture from my drone. That's not what I want to show you either. Okie dokie. Well, I guess I can't find it now, which is really annoying. I had it, but I don't think I saved it. That's not it. Let's just play this for a second.
Other side of the roof is totally sealed. They're almost done. This side of the roof, they won't be
You get
done.
some idea. It
though.
literally is a
They're
construction
missing
site here.
some
Everything is going. I don't
Might
even
be
have a
wrong.
furnace.
There's
So,
doorman acting like a daycare.
effectively, I'm basically living on a job site with no heating, no water. I have water in one tap, but I don't have no shower. I have a toilet that operates, but basically you're spending a lot. Okay, here's something. I'll give you some idea. This machine there is operating, and you can see how loud it is. So can you imagine me doing this versus Chris and crew doing this? Just take that in for a moment. Let me play it again. So you're doing that for in this case 9 hours for this particular pour, versus me doing this, which probably took me 100 hours. Okay, just so you know. Anyways, that's just an example. But let me go back to what I was looking for. I was trying to find for you. I drove along the driveway, and that's just a more pouring. But I drove along it at some point. I got to find out where that is. Nope. No, this is just annoying. This is annoying now. I probably can't find the damn thing. Oh well. Anyways, there's just all sorts of crazy things that happen. Let's see what this one is. What's this? No, it's just more concrete being poured. And you can just, again, just different angles. And Chris is operating the leveler, the vibrator. But I actually drove along here in a side-by-side, so you can drive the whole distance and you can see, whatever. But for some reason, I now can't find the damn thing, but that's all right. I'm not going to be too fussed about it. Yeah. I just come along until I find something here. No. Man. Bugger off. No. Well, anyways, this is me taking some drone shots at the job site. I don't know what we're going to get out of this, but you can see the house is torn apart. There's no deck. I'm landing, for crying out loud. It's not even exciting. It's not even exciting. Let's go back to something else. Let's see if we can. Oh, here we go. This is better. So here they're actually putting the roof in place using a crane. And you can see they're actually preparing the pads that we had to pour, which we've now poured. And in this case, they're actually putting the roof on. So they literally built the trusses. They put the trusses together and the walls. They put it all together on the ground and then lifted it up into sections onto the cement pad, which we had poured a couple weeks earlier. And you can see there's one of the walls right there on the ground waiting to be installed. Okay, so they'll get lifted up into place, and then their roof sections will get put into place. Yeah, and this is the job site. And it literally is a job site, right? Okay, so the crane will come in, and this can be expensive, right? You don't want to have to rent a crane and then leave it there overnight. That's a no-no. You get this work done. So these dudes were going to work until this is done. They will not be doing this, stopping, going home. So at 5 o'clock, they didn't just go home. They carried on working until it was finished. You're not going to pay for that kind of, you're not going to pay for the crane to come back. So again, I mean, and in this case, it was probably 30 Celsius. So they're working in the heat. They're working amongst stuff. It can be dangerous, by the way. And you can see here, they aren't wearing harnesses and stuff like that. I had some other better ones where the guys were walking along the edge walls here when there was nothing here. It was pretty impressive, the balancing that they were doing. But all of this I would have done when I work with my brothers. This has been contracted out, and I'm just responsible for signing off on things. So just to give you an idea of the job site. Okay, so let me get rid of this stuff. Anyways, that's my story. So I just want to end with one simple thing, and that is this is not as hard as whatever. That's not it. Right, this is just not as hard as the work that these guys are doing, okay? I don't care what any of us think. Is that it?
We used our side-by-side to bring in...
Stupid. Now I'm swearing. I gotta try not to swear. Yeah, like, it's just not as hard.
Plus minus 4 more trucks to finish.
You know?
It's going to take
so
them a while.
They
5
poured
o'clock already, or after
366
5,
feet
so
in 9
they'll
hours.
probably be here till 7 pouring.
Luckily, the weather was great. Everything worked. That's not as hard. That's harder than this. Okay? Now, to be fair, I don't get paid to do this right now. I get paid to make sure these guys have poured concrete. But anyways, that's another story. So for all of you watching this, or whoever watches this, just remember, the dudes laying concrete are working their asses off so that you can do astronomy. So try to keep that in mind. You know, when you're walking down the street and you see some poor schmo sweating their backside off out there working, you know, him or her, they're going to just, you know, they pay for us. They pay for us. End of story. Okay? Now on this job site, I'm not going to go into any detail. I won't talk about the demographics and stuff like this. This job site really we've had people from literally all over the world working on it. So we have Moldovans doing the tiling. We had a crew from Mexico doing the drywall. We had people from, where the heck were they from? The Ukraine? They were painting. Most of these guys here, one guy was from Nepal. Half of them are Canadian. A couple are Mexican. One guy's from Nepal. The guys doing the framing and that are all from Newfoundland, so the other side of Canada. So we've really had a hodgepodge of people coming in and out, you know, working on doing various jobs. It's actually pretty amazing. One of the I think that we only had one woman driving one of the cement trucks. So that was sort of that. Anyways, just kind of interesting. You get this real mix of what's going on in the world. Now in the trades, it's largely male oriented. It's just the way it is. Okay, at least it is here. It will be less so elsewhere, but it is here. All right, but they're from all over the place. So you have people from totally different backgrounds and whatnot. And the same is true in astronomy. Like if you go to an observatory, typically the observatory will have a lot of people from the country it's situated in. But when you look at the researchers in that and some of the people working there, you'll find they're from all over the world. So it's funny, you know, when I was young, this was completely just Canadians, you know. Now it's much more cosmopolitan, as much as the astronomy is. Just a matter of interest. So that's just an aside from what it is we're doing. But please don't think that doing this is as hard as that. And more importantly, try to give back for doing it. So thank you for your time. I hope you have a good evening. Enjoy yourselves. Let me see if